Thank you and welcome to our Gate 5.5 presentation. This is Team 2, designing the asparagus harvesting robot. Our client is UTEC. So our problem statement is how Peru is the second largest producer of asparagus in the world, which greatly contributes to the food and supply chain in Peru and many surrounding countries in South America. And there are many consistent issues with asparagus harvesting, such as labor shortages, working conditions, and labor availability that all negatively impact and contribute to the production and supply of fresh asparagus. And so our job was to develop an engineered mechanism to aid in harvesting that could be the solution to improve production and cost of food.
So for our project description, it was to design a semi-autonomous asparagus harvesting robot that utilizes computer vision and other sensor technologies to do the following, which is localize asparagus stalks in 3D space, determine which asparagus spears are adequate for harvesting, and grasp and cut these asparagus stalks without damage to the plant.
As for the task delegation between two universities, UTEC is responsible for building the full robotic platform that our system relies on. Their team designs the overall vehicle, including the powertrain, autonomy, and all of the mechanical, electrical, and control system that keeps the robot running in the field. They also develop the crop collection bins and storage system that will receive the harvested asparagus. And for our Purdue team, they focus on the harvesting side. We develop the computer vision and machine learning model that identifies mature asparagus, and we design and prototype the Cartesian mechanism that positions the arm. And at last, we also create and integrate the end-of-arm tooling that performs the actual harvesting and cut. And the final integration of this was completed on November 30 to December 6.
As for our design evolution, we went through many evolutions, both with the Cartesian and the gripper systems. The Cartesian used to be a belt drive system, and then we since pivoted to a ball screw system, which is now our final. And as of the gripper, we had a single motor design initially that we now updated to a two-motor design, one for the gripper and one for the cutter. And we installed a foam to increase the gripping for the asparagus.
And this is just a video of the cart system that UTEC designed. So it should be able to move back and forth as needed based on a code. And
¿Cuánto es y cuánto llega?
The back of the system, there's a camera, so the whole thing is designed and guided by a camera system. And this is just a video of our Cartesian model working in progress. So currently it's attached to the cart system that UTEC designed, and it's fully able to work based on code inputted by the computer vision of the camera. It's able to go to the exact coordinates it does. It's first going to grasp and then cut the system, and then it's able to carry it to the designated location where the basket would go.
I can do it in my board. So if it's 58, you round it up to 59 because that's more lower. And your max is 60, right? Right. So what I was saying that the Z, if it's like less than 57. So this asparagus is at 45 centimeter. This is at 40, and this is around 30 centimeter. It's like 10, 20, and 30. Okay. So it's able to detect all of them. The middle one is 30 centimeter, like 31.9. The right one is 41.2, and then the very first one is 45.4.
As far as the results go, so the machine generally performed as expected. Some smaller issues that could have been worked out and tweaked if we had longer time to work on it. One of the biggest comparisons that we noticed is the machine performed in a smaller working area than previously expected. We had to account for the gripper size and also the frame. A little bit of miscommunication, but it worked out well, although it was smaller than expected. Some of the recommendations that we came up with through this project is firstly try to keep focus on the CAD models and keep them up to date and as accurate as possible. That could have avoided a lot of miscommunication, and it's easy to go back and reference to see sizing and how things are going to work and kind of put your voice into images, which definitely helps. It's important to budget for time to tweak and work out small problems. We constantly ran into small issues and things like that, so it's good to get the big things done first so you can account for unexpected things to arise, which inevitably will happen. And lastly, just to keep it as simple as possible. Less equals less to go wrong, so try to use already manufactured pieces, try to look into other examples that already exist and kind of base your model off of that and to kind of learn from mistakes from other people.
Thank you for your time and attention. Go Boilermakers.